Welcome, dear friend, to Luminous Uplift, a gentle place where wonder and stillness meet, where the great mysteries of the universe are whispered softly, like a lullaby carried on starlight. We are so glad you found your way here tonight. Perhaps your day was long, perhaps your mind still holds the quiet weight of 100 small things. Let it all go now. Breathe slowly. Let your shoulders soften and allow yourself to simply be still. You are safe here, and tonight, something truly extraordinary awaits you. Here at Luminous Uplift, we tell stories that lift the spirit without disturbing the soul. Peaceful, luminous tales drawn from the deepest wells of science and human curiosity. Tonight, we journey together beyond everything familiar, riding alongside a tiny golden spacecraft named Voyager as it drifts through the vast velvet darkness beyond our solar system. Imagine the silence out there, the breathtaking loneliness, and the impossible beauty of floating between the stars, carried gently by the momentum of a single faithful launch made decades ago. If these kinds of serene explorations bring you comfort and wonder, we warmly invite you to like this video and subscribe to our channel so we may meet again on future journeys. No pressure, only an open door. Now, let us begin our journey outward, upward, and peacefully into the dark between the stars. There is something about the early morning hours, those soft and tender hours before the world has fully decided to wake up, that feels like it belongs to a different kind of time altogether. Not the time of clocks and calendars and carefully kept schedules, but the older kind of time, the kind that moves like water through fingers, slow and cool and impossible to hold. On the morning of September 5th, 1977, the sky above Cape Canaveral was that particular shade of deep and breathing blue that only exists in the last few minutes before the sun begins its patient climb above the horizon. The kind of blue that seems to hum softly to itself. The kind of blue that makes you feel, if only for a moment, that the world is still very young. The grasses along the Florida coast were damp with the night's quiet work, and the air carried that familiar salt and morning smell that coastal places always seem to hold on to, even as everything else around them changes. Somewhere out over the water, birds were beginning their slow conversations with the coming light. And in the middle of all that gentle, unhurried stillness, there stood a rocket. It rose up from the launch complex like a lighthouse that had decided, just this once, to see what was out there beyond the horizon it had spent so long watching over. It was called a Titan Centaur rocket, and it was a tall and serious and rather beautiful thing, the kind of machine that makes you feel a little breathless just looking at it. Not because it is threatening, but because it represents something very particular about the human spirit, that restless, reaching, wondering part of us that has always tilted its head back to look at the stars and asked very quietly, "What are you?" At the very top of that rocket, nestled inside its protective shell, like something precious wrapped carefully before a long journey, sat a spacecraft called Voyager 1. If you had been standing nearby and someone had told you that this small thing, this object that weighed only 825.5 kilograms, lighter than a small family car sitting in a driveway on an ordinary Sunday afternoon, was going to become the farthest traveling object ever made by human hands, you might have smiled politely and then looked back at the sky, not quite believing it. It is one of those facts that sounds like something someone made up to make the universe feel more magical than it already is. And yet it is simply, quietly, extraordinarily true. The people who had worked to bring this moment into being had spent years in the careful, patient way that scientists and engineers spend years, surrounded by calculations and blueprints, and conversations that ran long into evenings that smelled of coffee and possibility. They had chosen this particular morning, this particular September, for a reason that feels almost like something from a story told around a fire on a cool autumn night. The planets you see do not always line up in ways that are useful to a small spacecraft with a long way to travel. Most of the time, they are scattered across the solar system in arrangements that are beautiful to look at, but inconvenient for navigation. But every 176 years, something rare and quietly wonderful happens. Jupiter and Saturn, and Uranus and Neptune, those great slow giants of the outer solar system, drift into an alignment that allows a spacecraft launched from Earth to visit all of them, one after another, using each planet's gravity like a series of gentle helping hands, each one passing the traveler along to the next with a kind of cosmic generosity that makes the whole arrangement feel almost intentional. 176 years. Think about what that means for a moment, in the slow and easy way you might think about something, while lying in the dark listening to the sounds of your home settling around you. It means that the last time this alignment was available, the year was 1801. Napoleon Bonaparte was consolidating his power in France. The population of the entire planet Earth was somewhere around 1 billion people. The steam engine was still a relatively new and astonishing invention. No one had yet taken a photograph, or sent a telegram, or heard recorded sound. And the next time this alignment will come around again will be in 2153, when the world will be something none of us can quite imagine. That is how narrow and how precious this window was. And on September 5th, 1977, humanity climbed through it. There are moments in the history of human exploration that feel, in retrospect, like they always had a kind of inevitability to them, like they were always going to happen exactly as they did, at exactly the time they did, and all the human effort and ingenuity that went into making them real was simply the universe nudging its own story forward. This was one of those moments, and yet it did not feel inevitable to the people who were there. It felt hard-won and fragile and enormously, tremble-inducingly real. When the engines ignited and the Titan Centaur rocket began its slow gathering rise from the Florida coast, the sound it made was the kind of sound that you feel in your chest before you hear it with your ears, a deep, rolling, physical thing, like thunder that has decided to stay a while. And then it rose, slowly at first, the way big things always seem to move slowly, even when they are moving faster than the mind is comfortable imagining. It pushed up through that pre-dawn blue, through the thin layer of morning cloud that had gathered overnight, and into the higher air where the sky begins to deepen and the stars, if it had been dark enough, would have seemed a little closer, a little more reachable. Once clear of Earth's thick and nurturing atmosphere, Voyager 1 was traveling at roughly 10 kilometers per second. 10 kilometers per second. That is a number that the mind accepts with a polite nod before quietly admitting that it has no real idea what it means in any felt, embodied sense. 10 kilometers per second means that in the time it takes you to take one long, slow, sleepy breath, the spacecraft had already traveled the length of a small country. It means that the distance between London and New York, a journey that takes a modern jet aircraft something like 7 hours, would have taken Voyager 1 less than 2 minutes. The universe is very large, and even at 10 kilometers per second, there is a great deal of traveling ahead. But before we follow Voyager 1 out into the dark and the cold and the magnificent distances of interplanetary space, there is something we need to stay with for just a little while longer. Something that was tucked inside that spacecraft alongside its scientific instruments and its antenna and its power systems. Something that in some ways is the most extraordinary thing about this whole extraordinary story. It was a disc, a golden disc 12 inches across, made of copper and plated with gold, the kind of object that feels weighted with meaning even before you know what it contains. It was called the Golden Record, and the story of how it came to be aboard Voyager 1 is itself a story that deserves to be told in the soft, careful voice one uses for things that matter. Carl Sagan was a scientist and a dreamer and a poet of the cosmos, a man who understood that the universe was vast and strange and ancient, and who also understood, with a tenderness that came through in everything he wrote and said, that this small, warm planet with its blue oceans and its breathing forests and its billions of complicated, wonderful, confused human beings was precious beyond any calculation. He was asked to lead the committee that would decide what to put on the record, what to send out into space as a kind of message in a bottle, a greeting from Earth to whatever, whoever, might someday find it drifting in the dark between the stars. The task was, if you think about it for more than a moment, almost impossibly large. How do you choose what to say when you are speaking, potentially, to the entire rest of the universe? How do you distill a planet, a civilization, a species, into something that fits on a 12-inch golden disc? Carl Sagan and his committee thought about this with the seriousness and the love it deserved. They gathered together sounds and images and music from every corner of the Earth, a kind of time capsule and love letter and introduction all at once. They included greetings in 55 human languages, ranging from the ancient and storied to the living and still evolving. They included music, 90 minutes of it, from cultures and traditions spread across the full breadth of human history and human geography, from the intricate structures of Bach to the rolling rhythms of Azerbaijani folk music to the lilting beauty of a Peruvian wedding song. They included diagrams and encoded images that showed what human beings look like, where in the galaxy we live, what our sun looks like from the outside, and how our DNA is structured. They thought about what a visitor from somewhere else, somewhere unimaginably far, would need to know in order to understand what kind of creatures had built this small, improbable, gold-plated thing and sent it spinning out into the void. And they included sounds, the sounds of Earth, real, particular, irreplaceable sounds that when you close your eyes and really listen to them, feel like the most precious things imaginable. The sound of surf breaking on a shore where the water has been breaking for millions of years before any human being was there to hear it. The sound of wind moving through the leaves of trees in some forest somewhere. The specific rustling sound that leaves make when the air is warm and the afternoon is long. The sound of a mother speaking softly to her child in a language that has been spoken by human mothers for thousands of years. The sound of birdsong at dawn, that first brave declaration against the silence of the night. The sound of a train and a tractor and a dog barking somewhere in the distance in the way that dogs have always barked, full of urgent feeling and not quite sure why. The sound of rain, gentle and persistent rain, the kind that falls on windows at night while you're lying safely indoors and makes you feel, despite everything, that the world is a good place to be. The laughter of children, and perhaps most quietly astonishing of all, the sound of one single human heartbeat. Not a symbolic heartbeat, not a recording of some idealized cardiac rhythm, but a real heart beating in the chest of a real person, the small and steady sound of a life being lived. There is something about the decision to include a heartbeat that stops you if you let it. A heartbeat is the most intimate of sounds. It is the first sound we hear before we are even born, before we have eyes to open or words to learn or any knowledge at all of the world we are entering. It is the sound that tells us from the very beginning that we are not alone. And here it was, pressed into gold, sealed inside a spacecraft about to be launched at 10 kilometers per second toward a set of planets and then beyond them, into the spaces between the stars where the silence is so complete it has never been broken by anything so warm or small or alive. The heartbeat of a human being, sent out to speak for all of us into an emptiness so large that the mind retreats from the edges of it rather than try to look directly into it. The committee chose with care and with love and with the particular kind of seriousness that arises when you know that what you are doing will long outlast you. They argued about some choices and agreed quickly about others. They worried the way thoughtful people always worry when faced with an impossible task, that they were leaving out things that mattered, that somewhere in the vast archive of human experience and human beauty, there were sounds and songs and images that deserved to be there, and that they had not thought of. But eventually the choices were made, because choices must be made, and the record was pressed and plated and inscribed with instructions for how to play it. Instructions written in the universal language of mathematics and diagrams, addressed to whoever, in whatever form, might someday hold it in their hands or whatever it is they use instead. And as that golden disk was sealed inside the spacecraft, carrying with it the sound of rain and the laughter of children and one single human heartbeat, no one quite knew just how far, and as that golden disk was sealed inside the spacecraft, carrying with it the sound of rain and the laughter of children and one single human heartbeat, no one quite knew just how far it might travel before something, or someone, might hold it gently in whatever hands they possessed. And perhaps that is the most tender thing about it. Not the engineering, extraordinary as that was, not the mathematics, precise as it had to be, but the simple, almost unbearable hopefulness of the gesture itself. A species barely a breath old in cosmic time, reaching outward into a darkness so vast it had no name in any of the 55 languages recorded on that disk, and saying softly, "We were here. We existed. We made things. We loved." Let that settle over you for a moment, the way a warm blanket settles over sleeping shoulders. The year was 1977, and the world was moving fast in the way the world always moves, full of noise and worry and the ordinary business of living. But somewhere in the hum of that ordinary year, a small group of people sat together and asked themselves one of the strangest, most luminous questions a human being can ask. If we could send a message to someone we will never meet, in a time we cannot imagine, across a distance we cannot truly fathom, what would we say? What would we choose to carry? What would we dare to call essential? Carl Sagan, who had a way of looking at the universe and finding it both vast and intimate, led the team that would answer those questions. And the answer they arrived at was not a list of our achievements, not a catalog of our cities or our weapons or our political systems. It was something softer and stranger and more honest than any of that. It was a portrait of what it feels like to be alive on a small, wet, improbable planet spinning quietly around a middling star in one of 100 billion galaxies. The record itself is a physical object of extraordinary beauty, and it helps to imagine it clearly, to let the image of it rest in your mind as you breathe slowly and let the day release you. It is a disk of copper, plated in gold, golden in the way of late afternoon light on still water. Gold was chosen not for its glamour, but for its patience, for its willingness to endure without tarnishing, without rusting, without surrendering to the slow erosion that takes almost everything else. Gold is a material that understands waiting, and this disk would need to wait a very long time. Scientists believe the golden record, sealed inside its aluminum cover and drifting through the cold, perfect vacuum of interstellar space, will remain intact for over 1 billion years. 1 billion years. The mind reaches for that number and finds it cannot quite close around it, the way a child's hand reaches for the moon. 1 billion years ago, the most complex life on Earth was soft-bodied and silent, drifting in shallow seas, not yet having dreamed of bones or breath or the particular ache of looking up at stars. And yet, in 1 billion years from now, this small copper disk may still be spinning gently through the dark, carrying its cargo of human tenderness completely unharmed. There is something about that which makes the chest feel full in a quiet way, something between grief and wonder, something that has no clean name but feels important to hold anyway. On the outside of the record's cover, etched with the same care you might use to write a letter to someone you love very much, is a set of instructions, a diagram, precise and elegant, showing any finder not only how to play the record, but how to find us. Pulsar maps are included, maps that use the unique timing signatures of pulsars, those rapidly spinning stellar remnants that pulse with the regularity of cosmic clocks, to triangulate the position of our sun in the galaxy. Every pulsar has its own rhythm, its own beat, as individual as a fingerprint, and together they form a kind of address, a way of saying, "We live here, this is our neighborhood. This is where you might find the planet that made this thing." It is an act of extraordinary trust, when you think about it, to leave your address in the darkness, to say, "Come find us," or simply, "We wanted you to know where we stood." There is also on the cover something that sounds strange at first, but reveals itself as beautiful upon reflection. A thin layer of uranium-238, not as a threat, not as a boast, but as a clock. Uranium-238 decays at a known and steady rate, a rate so reliable it is one of the ways scientists measure the age of ancient rocks and distant geological events. Any civilization advanced enough to retrieve this record and examine its cover would presumably understand radioactive decay, and so they would look at the uranium, measure how much had transformed in the long years of the disk's journey, and calculate with a reasonable degree of accuracy, not just when the record arrived, but when it left. They would know when we launched it, which is to say, they would know when we existed, when we were here making music and sending messages and wondering whether anyone might one day wonder back. There are 116 images encoded on the record. They are not images of monuments or palaces or famous faces. They are images of the kinds of things that make a life, the kinds of images you might gather if someone asked you to explain to a stranger what it means to wake up on a morning on Earth and simply be alive. There is a diagram of the solar system. There is an image of a sunset. There is a sequence showing human anatomy, a fetus developing inside a womb, a newborn held close. There are pictures of insects and flowers, and a woman in a supermarket reaching for food, and a man eating and a child touching the face of a globe with one wondering finger. There is an image of the ocean at night, a traffic jam, an airport, a family sitting down to dinner. Each image small on its own, and yet together they accumulate into something that feels almost unbearably human. A mosaic of the ordinary made suddenly luminous by the knowledge of how far it would travel and how long it would endure. And then there is the music. 90 minutes of it, drawn from across the full reach of human musical tradition, gathered from every corner of the world with the same quiet seriousness you might bring to choosing what songs to play at a moment that matters very much. There is Bach, the cool and intricate beauty of the Brandenburg Concerto, notes arranged with such mathematical grace that they feel almost like an argument for the existence of meaning itself. There is Chuck Berry, bright and irreverent and dancing, the kind of music that makes the feet want to move even when the body is exhausted. There is a Navajo night chant, its tones rising and falling like breath, like the rhythms of something much older than language. There is Azerbaijani bagpipes and the panpipes of Solomon Islands, and a Senegalese percussion piece, and a Mexican mariachi, and the stalactite caves singing of Georgia, and a Japanese shakuhachi flute drifting through notes that sound like longing made audible. There is an Australian Aboriginal song, and a Peruvian wedding song, and a raga from India, classical and ancient and slow as the turning of seasons. Someone on the selection committee, moved by a kind of cosmic mischief or perhaps simple wisdom, included Louis Armstrong playing melancholy blues. You can imagine Armstrong's trumpet floating now through the dark between stars, that warm and aching sound moving through a silence so total that even the concept of sound barely applies, and yet carrying within it something completely indestructible, something that no amount of distance or time can quite erase, which is the very particular human feeling of longing, of love, of knowing that beauty is brief and playing it anyway. The natural sounds woven through the record are the ones that tend to quiet the mind the most, if you let them. There is the sound of ocean waves, that endless patient rhythm of water meeting shore and retreating again, as it has done since before there were creatures alive to listen to it. There is wind moving through leaves or through emptiness. It doesn't matter. Just the sound of air in motion, the planet breathing. There is thunder, that deep, low rumble that means weather and distance, and the power of systems far larger than any single living thing. There are birds, their calls bright and precise and particular, each one a small event, a small announcement that the morning is here and worth noting. There is the sound of mud pots, of rain on different surfaces, of a tractor moving through a field, of the human body walking on packed earth. There is, most quietly and most significantly, the sound of a mother speaking her first words to a newborn child. We do not know what language she spoke in that moment. We do not know exactly what she said, but we know the sound of it, and so does every living creature that has ever been held close in the beginning. It is the sound of arrival, of welcome, of you are here and you're not alone. The greetings recorded in 55 languages range from formal and dignified to simple and warm, and sometimes a little helplessly charmed by the strangeness of the task. In ancient Akkadian, a language no one has spoken aloud in thousands of years, there is a greeting. In Welsh, in Cantonese, in Amoy, in Oriya and Rajasthani and Nepali, in ancient Greek. In English, a United Nations Secretary General says, with great formality and evident sincerity, that this is a gift from a small, distant world. The very youngest voice belongs to a child, Carl Sagan's son, Nick, who was 6 years old at the time, and who simply said in a voice that sounds exactly like what it is, a child speaking carefully, "Hello from the children of planet Earth." That voice has now been traveling through space for nearly 50 years. Nick Sagan is no longer 6 years old, but that voice, that small and earnest hello, will be traveling still when the sun has grown old and cooled, and the planet that produced it has long since changed beyond recognition. Something about that fact deserves a moment of quiet acknowledgement, a small inner pause, because it is both very strange and very beautiful, and it does something complicated to the ordinary sense of time. All of this, every image and sound and greeting and musical passage, was chosen and organized and inscribed onto a disc of gold-plated copper that is roughly the size of an old vinyl record, something you could hold in 2 hands without effort, something a child could carry. It was then sealed inside the Voyager spacecraft, first Voyager 2 in August of 1977, and then Voyager 1 a few weeks later in September, and sent upward and outward into the dark. Both spacecraft have now crossed the heliopause, that invisible boundary where the sun's influence finally gives way to interstellar space. They are, at this moment, the most distant human-made objects in existence, farther from us than any human artifact has ever been, and still moving, still carrying their golden cargo with the same indifference to distance that empty space always shows. The record does not know it is precious. It does not know it is a message. It simply is what it is, and it endures. There is a particular kind of peace that comes from thinking about this, if you allow yourself to settle into it without rushing, the way you might settle into warm water. The peace comes from the scale of it, paradoxically, because when you truly feel the distance involved, when you truly let yourself understand that these records are sailing through a darkness so wide and so deep that the entire history of human civilization would fit into the smallest imaginable fraction of the journey that still lies ahead. Something in the ordinary anxieties of daily life begins to soften around the edges. Not because the anxieties aren't real, they are, but because the universe is so much larger than any of them, and the fact that humans looked into that vastness and decided to send it something kind, something musical, something that said, here is what we found beautiful, here is what made us feel, here is the sound of our ocean and our storms and our smallest creatures singing at dawn. That fact is genuinely consoling in a way that is difficult to explain, but easy to feel. The record will not reach another star system for tens of thousands of years. By that measure, it has barely left. It is still, in cosmic terms, practically at home, still in the neighborhood, still close enough that the light from our sun is the brightest thing in its sky. And yet it is already beyond any possibility of retrieval, already committed to its journey, already gone in the way that certain moments are gone, the instant they have been fully felt. Someone once said that sending the golden record was an act of hope almost too large to hold, and that seems right. Not hope as in expectation, not hope as in confidence that something will definitely happen, but hope as in the act of reaching anyway, of saying even so, even into this impossible dark, we offer what we made, we offer what we loved. We offer, without condition and without certainty, the sound of everything we thought was worth keeping, and tucked inside that copper disc, the sound of a Beethoven string quartet, drifted outward into the dark alongside the whisper of a pygmy girl's initiation song. both equally small and equally infinite against the silence of tucked inside that copper disk. The sound of a Beethoven string quartet drifted outward into the dark alongside the whisper of a pygmy. Girl's initiation song, both equally small and equally infinite against the silence of space, which does not distinguish between the ancient and the new, between the loud and the soft, between the thing that was made in a concert hall in Vienna and the thing that was sung in a forest older than any city. Space holds them all with the same indifferent tenderness, the way a river holds both a stone and a feather, carrying them along without preference, without judgment. Simply onward and onward through the dark. And onward was exactly where Voyager 1 was going. By the time the last notes of that golden record had been encoded, by the time the last human fingerprint had been pressed into the metal casing and the last bolt had been turned into place, the spacecraft was already being prepared to leave not just the Earth behind, but the entire inner neighborhood of our solar system. It would soon cross a boundary that, for most of human history, had existed only as a mystery, a region somewhere out there between the rocky planets and the giants. A place where ancient debris floated in slow circles, patient and unhurried, remnants of a world that never quite managed to become one. We call it the asteroid belt. If you have ever seen it depicted in a film, you may carry an image of it as something dangerous and chaotic, a churning field of tumbling rocks packed so tightly together that flying through it feels like threading a needle at full speed, explosions narrowly avoided, boulders glancing off hulls, alarms shrieking. It is a dramatic picture. It is also, like so many dramatic pictures, wonderfully wrong in all the most interesting ways. The asteroid belt is, in truth, one of the most peaceful places in the solar system. Imagine standing in the middle of a very large room, a room perhaps the size of a football stadium, and somewhere in that room there are 3 or 4 grains of sand. That is roughly the density of the asteroid belt. The rocks are there, yes. The boulders are there. Ceres, the largest body in the belt, is there, round and gray and quietly dignified, large enough to be considered a dwarf planet, slowly turning in its orbit as it has for billions of years. But between Ceres and its neighbors, between any one rocky fragment and the next, there are distances so enormous that you could travel through the entire belt without ever coming within sight of a single asteroid. This is what Voyager 1 discovered, in the most practical sense, simply by passing through without incident. The belt spans a tremendous stretch of space, roughly 140 million miles from its inner edge, near Mars, to its outer boundary near Jupiter. That number is almost impossible to feel in the body, the way that most numbers of this scale are impossible to feel. 140 million miles. If you were to drive that distance in a car at highway speed, without stopping, without sleeping, the journey would take you something like 2,500 years. You would have started driving before the fall of Rome, and you would still be going. The radio would have gotten very tedious. The snacks would have run out. And yet, through all of that distance, through all of that vast and ancient quiet, Voyager 1 moved like a thought, not a fast thought, not by the standards of what it would later achieve, but steady and sure, a spacecraft that had been given a direction and simply held to it, trusting the physics, trusting the mathematics, trusting the invisible architecture of gravity that holds the whole solar system in its gentle web. There is something deeply calming about the way the asteroid belt actually looks, if you imagine it honestly rather than cinematically. Picture a slow river of light. Picture a darkness so complete that the stars behind it are perfectly visible, unobstructed, each one a needle of silver in the black. And drifting through that darkness, here and there, sometimes millions of miles apart, the occasional tumbling rock, gray and pockmarked, rotating slowly on its own private axis, minding its own ancient business. Some of them are round, some of them are jagged, some of them look like broken teeth, and some look like sleeping animals curled against the cold. They have been there for 4.5 billion years, these rocks. They remember a time before the Earth had oceans. They remember, in the way that rocks remember things, a time before anything alive had ever opened its eyes on any surface anywhere in our solar system. Voyager passed through them all without so much as a scratch. This is part of why the engineers and scientists back on Earth watched the crossing with something that was probably equal parts professional confidence and quiet personal relief. The mathematics said it would be fine. The density calculations said the probability of a significant collision was vanishingly small. But there's always a difference between what the numbers say and what the heart feels, and more than one person in that control room probably exhaled just a little more slowly when the spacecraft emerged from the other side with all its instruments still talking, still transmitting, still alive in every sense that a machine can be alive. On the other side of the asteroid belt, the solar system changes. It becomes a different country. The light from the sun, already dimmer than it would be on Earth, dims further still. The temperature of space, always cold, settles into a cold so deep it becomes almost philosophical. Out here in the realm of the giant planets, the scale of everything shifts upward in a way that takes a moment to absorb. The inner solar system, with its 4 small rocky worlds, its dust and its iron and its thin atmospheres, begins to feel like a brief preamble, a short introduction to something much grander and stranger. And the grandest, strangest thing of all was waiting just ahead: Jupiter. Jupiter is not simply a large planet. Jupiter is a planet of a completely different character than anything in the inner solar system. A world so massive that all of the other planets combined could fit inside it, and there would still be room left over. It is made almost entirely of gas and cloud and liquid, a world with no surface to stand on, no shore to walk along, just layer after layer of atmosphere descending into depths we have never seen and perhaps could never survive long enough to see. Its storms are older than human civilization. Its winds move faster than anything that blows on Earth. It is, in every sense, extravagant. Voyager 1 reached Jupiter in March of 1979. It had been 18 months since launch. 18 months of silence and distance and the long, patient drift through interplanetary space. 18 months of the spacecraft operating as it was designed to, collecting data, adjusting its orientation, sending home signals that took increasingly longer to arrive as the distance grew. 18 months of engineers monitoring readouts and scientists sharpening their predictions, and everyone, in the quiet, professional way of people who have given their working lives to something large and important, waiting. When Jupiter finally resolved from a point of light into something real, something with features and weather and color, the images that came back were unlike anything that had been seen before. They were beautiful in the way that things are beautiful, when they are both familiar and completely alien at the same time. The banded clouds of Jupiter, the pale cream and deep amber and rust-red stripes that wrap around the planet in parallel rivers of wind, were visible in detail that no telescope on Earth had ever managed. The Great Red Spot, that enormous storm system that has been churning in Jupiter's southern hemisphere for at least 350 years, possibly much longer, appeared in photographs as something almost geological in its permanence. A wound in the atmosphere that had been there when Shakespeare was writing his plays and was still there now. Patient and vast and entirely indifferent to the passage of human time. But the storm was not the greatest discovery waiting for Voyager at Jupiter. That distinction belongs to a small moon, the innermost of the large moons of Jupiter, a world not much bigger than our own moon, golden and red and scarred in ways that no one had quite anticipated. Its name is Io. And when Voyager's cameras turned toward it and the images began to come back, and the scientists crowded around the monitors, what they saw was something that rearranged a small but important piece of how we understood the universe. Volcanoes. Active volcanoes. Not the cold, dead remnants of ancient geological activity. Not the frozen evidence of eruptions long past, but live, working, erupting volcanoes. Plumes of sulfur and silicate rising hundreds of kilometers above the surface. The moon essentially turning itself inside out in a continuous, violent process powered by the gravitational squeezing of Jupiter's enormous tidal forces. Before Voyager reached Io, the only volcanically active world we knew of in the solar system was Earth. We thought, special in this regard, unique, alone in our geological restlessness. Io changed that understanding in a single afternoon. It was the first time in the history of human exploration that active volcanoes had been seen on another world. The scientist who first identified the eruption in the images, a young woman named Linda Morabito, was processing navigation photographs when she noticed something strange along the edge of the moon. A faint umbrella-shaped cloud rising above the limb of Io, where there should have been nothing but black space. She looked at it for a long time. She checked her instruments. She checked the images again. And then she understood what she was seeing, and the solar system became a larger, stranger, more alive place than it had been that morning. Volcanoes on another world. Fire, in a manner of speaking, in the outer darkness. The universe proving, once again, that it is not finished surprising us. But Jupiter had one more gift for Voyager, and this one was not a discovery so much as a transformation. As the spacecraft swept around the great planet in a precisely calculated arc, Jupiter's gravity reached out and grabbed hold of it, not to trap it, but to throw it, to add its own enormous momentum to the spacecraft's trajectory in the way that a very large spinning wheel can accelerate a very small stone. This is what we call a gravitational slingshot, a gravity assist, a maneuver that exists at the beautiful intersection of elegance and practicality, using the natural physics of orbital mechanics to accomplish something that no amount of fuel alone could achieve. By the time Voyager 1 emerged on the far side of Jupiter's gravitational influence, it was moving faster than it had ever moved before. Over 35 kilometers per second. That is more than 78,000 miles per hour. That is fast enough to travel from New York to Los Angeles in something like 3 minutes. Fast enough to cross the entire United States in a breath. Fast enough to leave the inner solar system behind and never, ever come back. Jupiter gave Voyager its wings in a sense, or perhaps it gave it something better than wings, because wings require air, and there is no air out here. There is only the clean and frictionless physics of space, gravity bending trajectories, momentum carrying everything forward. the whole beautiful mechanism of orbital mechanics working exactly as the mathematics promised it would. The scientists who planned this slingshot had done so years before the launch, had calculated Jupiter's position to within extraordinary precision, had trusted that the planet would be exactly where they needed it to be, and it was, as planets always are, reliable and patient and right on time. Now Voyager was running. Now it was truly on its way, not just through the solar system, but toward the far edge of it, toward Saturn and beyond, toward distances that made the journey so far look like a short walk to the end of the driveway. The asteroid belt was behind it. The inner solar system was behind it. Earth by now was a pale memory of warmth and blue light somewhere far back along the trajectory, still faithfully receiving the spacecraft's signals, still sending commands, still listening. And Jupiter grew from a dot of light to a swirling amber world, so vast it could swallow 1,000 Earths whole. Its great storm spinning quietly as it had for centuries before any human eye had ever thought to. And Jupiter grew from a dot of light to a swirling amber world so vast it could swallow 1,000 Earths whole. Its great storm spinning quietly as it had for centuries before any human eye had ever thought to look so closely, to lean in with such wonder, to notice that circling this enormous amber god were worlds of their own, small and strange and patient, waiting in the dark, like lanterns hung at the edges of a very old dream. There are at least 95 of them, 95 moons circling Jupiter in their quiet ellipses, some no larger than a city, some tumbling slowly end over end like stones tossed into a still pond and never quite settling. Most of them we barely know. Most of them are small and dark and nameless in the way that distant things so often are, present but unhurried, requiring no acknowledgement to continue their patient revolutions around that massive amber light. They have been turning there since long before we arrived, and they will continue long after we have gone, indifferent to our wonder, and yet somehow made more beautiful by it. But 4 of these moons are different. 4 of them carry weight in the history of human thought, not just in science, but in the deeper story of what it means to look up and truly see. In the winter of 1610, a man named Galileo Galilei pressed his eye to a telescope he had built with his own hands, aimed it at Jupiter, and noticed something that no one had been prepared to notice. There were small points of light beside the great planet, and night after night, those points of light moved. They shifted position. They disappeared behind Jupiter and reappeared again on the other side. They were not stars. They were worlds circling another world. And suddenly, the universe was larger and stranger than it had ever been before. He named them, or rather, he tried to name them after the family of his patron, though history chose different names in the end, and those 4 moons became known as Io, Europa, Ganymede, and Callisto, the Galilean moons. 4 small syllables of light that changed everything. Because if moons could circle Jupiter, then not everything in the cosmos circled the Earth. The Earth was not the center. The universe did not revolve around us. We were just one world among many, nestled in a corner of something immeasurably vast, and the night sky was no longer a ceiling painted with fixed fires, but an infinite depth full of moving, circling, breathing things. That realization, born from 4 faint points of light beside an amber planet, echoes still, and it is worth sitting with for a moment, here in the soft dark, while the world outside your window breathes slowly and the night holds everything gently. More than 3.5 centuries after Galileo squinted through his eyepiece in the cold Italian air, a spacecraft called Voyager 1 arrived at Jupiter. It had been traveling for years, crossing the impossible distances of the outer solar system with the patience of something that has no choice but to be patient. And when it arrived, it turned its cameras on those 4 moons and sent back photographs. The first close-up photographs anyone had ever seen of worlds Galileo had discovered with nothing more than a handmade lens and curiosity. What those photographs revealed was something that even the scientists who had designed the mission were not entirely prepared for, because the moons of Jupiter, seen up close, were not what imagination had conjured. They were stranger, more vivid, more specific, more dreamlike, in the way that real things are sometimes more dreamlike than dreams. There is a particular quality of astonishment that comes not from the completely unexpected, but from the thing that is almost familiar, the thing that looks, for just a moment, like something you might recognize, before resolving into something entirely its own. These moons had that quality. They looked like worlds. They looked like places, and they looked like nothing anyone had ever seen. Consider Io. Of all the moons in our solar system, Io may be the most restless, the most tortured, the most alive with a kind of violent geological energy that makes our own volcanically active Earth seem placid by comparison. Io is slightly larger than our moon, and from a distance it looks strange, yellow and orange and white, mottled and marbled like a half-finished painting, or like the yolk of some impossible cosmic egg. Its colors come from sulfur, from the constant eruption and deposition of volcanic material across a surface that is never still, never settled, never allowed a moment's peace. What drives this? Gravity. The gravity of Jupiter, pulling at Io with enormous force, and the gravity of the other large moons, Europa, Ganymede, pulling in their own directions, creating a gravitational tug-of-war that squeezes and flexes Io's interior the way your hands might knead a piece of dough. This squeezing and flexing generates heat, enormous, relentless heat, and that heat drives volcanic activity on a scale that is difficult to fully absorb. There are volcanoes on Io that eject material hundreds of kilometers above the surface. There are lava lakes on Io that pool in flat basins, glowing with a heat that has no winter, no rest. The surface of Io is being constantly remade, constantly overwritten, constantly reshaped, so that whatever might once have been written there, whatever record of impact or ancient geology, has long since been erased and written over and erased again in a cycle as relentless as breathing. When Voyager 1 sent back its images of Io, scientists saw those volcanic plumes rising above the surface and understood for the first time that they were witnessing the most volcanically active body in the entire solar system, not Earth, not any of the rocky planets. This small, sulfur-painted moon circling a gas giant in the outer solar system, driven not by the decay of radioactive elements deep within, but by the gravitational squeeze of its enormous neighbor. Io burns because Jupiter loves it too fiercely. There is something almost poetic in that, if you let yourself feel it. Something about closeness and intensity and the price of being held so tightly by something so large. But now, gently, let your mind drift from the fire of Io to something quieter, something that carries a different kind of wonder, softer, more patient, more like a secret held beneath still water. Let your mind settle on Europa. Europa is the smallest of the 4 Galilean moons, though it is still immense, nearly as large as our own moon, smooth and pale and wrapped in ice. From a distance, it looks almost clean, almost simple. A white sphere, faintly blue, with none of the obvious drama of Io's volcanic yellows and oranges. But look more closely. Look at the surface of Europa, and you will see something extraordinary. It is covered in lines, cracks and ridges and reddish-brown streaks that lace across the ice like the lines on the palm of a very old hand, or like the surface of a hard-boiled egg that has been rolled gently across a table, its shell fractured into 1,000 interlocking shards, but still holding together, still whole. Those lines are where the ice has cracked and shifted and refrozen, and they tell a story. They tell the story of a surface that is not sitting still, not frozen in the ancient way of dead and static things, but moving. Slowly, quietly, almost imperceptibly, but moving. The ice of Europa floats. It floats on something beneath. And what is beneath is perhaps the most astonishing thing in the entire solar system, perhaps the most astonishing thing we know of anywhere in the universe within our reach. Scientists believe that beneath the icy shell of Europa, somewhere between 10 and 30 kilometers below that fractured white surface, there is a liquid water ocean. Not a frozen thing, not a suggestion of water, an ocean. A vast, dark, deep saltwater ocean that has been liquid for perhaps billions of years, kept warm not by the light of the distant sun, which barely reaches Europa as a faint and feeble glow, but by the same tidal forces that set Io's volcanoes burning. Jupiter's gravity flexes Europa too, though more gently, more quietly, generating just enough heat in its rocky interior to keep that water liquid in the absolute cold of the outer solar system. Think about that for a moment. Think about what it means. On the surface of Europa, the temperature is somewhere around -160 degrees Celsius. It is a place of profound, bone-deep cold, where the ice is hard as granite and the sun is just a bright star in a black sky. And yet, beneath that cold and silence, beneath kilometers of ancient ice, there is water, liquid water in the dark, moving in currents we have not yet observed, pooling in depths we have not yet measured, carrying in solution minerals and chemicals that have leached from the rocky seafloor below. It is an ocean hidden inside an ice shell, hidden inside a solar system that most people think of as cold and dead and empty. And where there is liquid water and heat and chemistry on Earth, at least, there is life. This is not a small thought. This is the thought that keeps astrobiologists awake at night in the most wonderful possible way. The hydrothermal vents on the floor of Europa's ocean, if they exist, and the physics suggests they might, would be structurally not entirely unlike the hydrothermal vents on Earth's ocean floor, where complex communities of organisms live without any sunlight at all, sustained entirely by the chemical energy of the venting water. Tube worms and bacteria and shrimp with no eyes, living in the absolute dark of our own ocean's deepest places, where the only light is the faint blue shimmer of bioluminescence and the heat glow of the vents themselves. Perhaps nothing lives in Europa's ocean. Perhaps it is simply water and rock and chemistry, beautiful in its own right, significant in its own right, without needing to contain anything alive. But perhaps something does, and the fact that we cannot yet say, the fact that the question is genuinely open, is one of the most remarkable things about this moment in human history. That we live at a time when such a question can even be asked, when we know enough to know that the asking is reasonable, and when the tools to eventually answer it are slowly, carefully being built. Now let your thoughts drift a little further, a little wider. Let them move from Europa's pale ice to the largest of these four moons, the largest moon in the entire solar system, a world so substantial, so planetary in its nature, that it bears the name of the king of the Titans, Ganymede. Ganymede is larger than the planet Mercury. Let that sit quietly for a moment. A moon, something circling another planet, is larger than one of the 8 recognized planets of our solar system. Ganymede has a diameter of more than 5,000 kilometers. It has its own magnetic field, generated deep within its interior, a feature that no other moon in the solar system possesses. It has a thin atmosphere, barely there, a wisp of oxygen so faint it would be invisible and unbreathable, but present, which is itself a kind of marvel. And like Europa, Ganymede is believed to hold liquid water beneath its surface, though perhaps sandwiched in layers between different kinds of ice, like the layers of some extraordinary geological cake built over billions of years. When Voyager 1 photographed Ganymede, it revealed a surface of extraordinary complexity, ancient dark terrain covered in craters, and younger, brighter terrain laced with grooves and ridges that record some ancient episode of geological activity, some convulsion in Ganymede's deep past that reshaped its surface and left these bright furrows like the marks of a great comb drawn across pale stone. Ganymede is a world with a history, with a geology, with a story written in its surface that scientists are still learning to read. And then there is Callisto, the outermost of the 4 Galilean moons, the most heavily cratered body in the solar system, a surface so saturated with impact craters that every new impact simply destroys the evidence of old ones. Layering crater upon crater upon crater in a record of ancient bombardment that stretches back nearly to the birth of the solar system itself. Callisto is old in the way that some things are old and somehow peaceful in their age, worn smooth in some places, pocked and ancient in others, carrying the marks of everything that has ever struck it with a kind of quiet, patient acceptance. Galileo saw all 4 of these worlds as nothing more than tiny points of light. He had no way to know what those points contained. The fire of Io, the hidden ocean of Europa, the impossible scale of Ganymede, the ancient patience of Callisto. He knew only that they moved, that they were real, that they mattered. And in that knowing, he changed the world as much as anyone who has ever held a tool of observation and had the courage to believe what it showed him. Voyager 1 carried human curiosity to the edges of the inner solar system and beyond, and when it turned its cameras on these moons, it gave us back something we had barely known we were missing: specificity, detail, the particular texture of real places that had existed for billions of years without us, that did not need us to be extraordinary, but became, through our seeing, something we could carry with us. Images, understanding, astonishment, the good kind, the kind that makes the universe feel larger and yourself feel quieter and more at peace with the strangeness of existing at all in such a place. And somewhere in the soft dark of your own mind, as you let these thoughts settle like snow falling slowly through still air, gentle, unhurried, each flake finding its place, perhaps you can feel something of what Galileo felt in that cold Italian winter, eye pressed to glass, watching those 4 small lights shift and move beside their great amber god. Perhaps you can feel something of what the scientists felt when Voyager's photographs arrived, pixel by pixel, from across the vast cold dark. That feeling of the world opening, that feeling of the floor of the universe dropping away beneath you into something deeper and more beautiful than you had quite realized was there. The moons of Jupiter have been circling in their patient paths for billions of years. They were there before the first fish swam on Earth. They were there before the first tree grew, before the first creature lifted its head and noticed the lights overhead. They do not know we are watching. They do not need to. They simply continue. Io burning, Europa dreaming beneath its ice, Ganymede vast and magnetized in the outer dark, Callisto cratered and ancient and still. And somewhere among the other 91 moons, the small, dark, tumbling ones, the nameless ones, the ones we are still learning to count, there are other stories we have not yet begun to read, other questions we have not yet thought to ask. But for now, let your mind rest gently on Europa. Let it hover there in the cold outer dark, that pale and cracked and quietly extraordinary world, lit by a sun too distant to warm encircling a planet too massive to fully comprehend. Let yourself feel the quietness of ice, the patience of deep cold, the strange and tender possibility of what might lie beneath. And Europa's cracked icy surface shimmered in Voyager's cameras like a pale blue eggshell wrapped around some secret, warmer world hidden miles and miles beneath, where perhaps in some quiet ocean cavern, something in Europa's cracked icy surface shimmered in Voyager's cameras like a pale blue eggshell wrapped around some secret, warmer world hidden miles and miles beneath, where perhaps in some quiet ocean cavern something small and improbable and utterly miraculous had learned over billions of patient years. The first shy grammar of being alive. We do not know, we cannot say with certainty, but Voyager gave us the question, which is perhaps the greatest gift any instrument of science has ever bestowed upon a curious and sleepy species, still pressed against the glass of their own small world, still learning to look outward with wondering eyes. And so Voyager continued its long, unhurried arc through the solar system, carrying with it the accumulated patience of everyone who had ever tilted their head back on a clear night and felt the universe pulled gently at something deep behind their chest. It had seen Jupiter's storms and Europa's ice, and the volcanic fury of Io painting itself in impossible colors against the black. It had lingered long enough to let us fall in love with each world in turn, and then, as all good travelers must, it moved on, drawn forward by the invisible geometry of gravity and time, curving its path outward and inward at once, threading through the darkness like a needle pulling a single bright thread through an endless bolt of black silk. What waited ahead was something that human beings had watched from Earth for centuries without ever truly seeing. Something that had caught the eye of Galileo when he pressed his crude telescope to the sky in 1610 and written in his journal, baffled and delighted, that Saturn appeared to have ears. He didn't know what he was looking at. Nobody did. Not really, not for decades. It was the Dutch mathematician Christian Huygens who, in 1659, finally suggested that what surrounded Saturn was not ears, not handles, not some strange planetary appendage, but a ring, a flat circular ring, tilted slightly toward us, catching the light like a coin held at an angle to a candle. Even that was only the beginning of understanding. Even that description, though it finally named the shape, could not begin to account for what those rings actually were, how they were made, what they were made of, how thin they truly were, how intricate, how ancient, how quietly astonishing. All of that waited for Voyager. Voyager 1, reached Saturn in November of 1980, and when it did, it carried with it the eyes of humanity. All of us who had ever looked up at Saturn through a backyard telescope and caught that first impossible glimpse of those rings tilted in the darkness. That perfect impossible halo floating around a golden world, so unreal looking that children sometimes assume they are seeing a sticker, a toy, something someone has placed in the eyepiece as a joke. Saturn doesn't look real. It never has. It looks like something dreamed by a mind that loved elegance too much to settle for anything ordinary. A mind that decided if you were going to make a planet, you might as well make it breathtaking. Voyager 1's cameras turned toward Saturn the way you might turn your face toward a window at dawn. Slowly, reverently, letting the light arrive. And the light it found there was extraordinary. Saturn sits much farther from the Sun than Jupiter, nearly 10 times farther from our star than the Earth. And so the sunlight that reaches it has already traveled a vast and tiring distance. It arrives quieter, softer, less insistent than the light that beats down on the inner planets. And when that gentle, aged light falls upon Saturn's rings, something happens that is very hard to describe without reaching for poetry. The rings are made almost entirely of water ice. Not rock, not metal, not the stuff of mountains or valleys, but ice, frozen water, shaped by billions of years of cosmic chance into particles ranging from tiny grains, smaller than a snowflake, to boulders, several meters across, tumbling and drifting and slowly orbiting the great golden planet below. Some of these ice particles are almost perfectly reflective, polished by their long existence in the cold vacuum of space into tiny mirrors that catch whatever light reaches them and throw it back into the darkness with remarkable brightness. Saturn's rings are, in a sense, made of scattered light, a vast and slowly rotating mosaic of ice and reflection, each tiny fragment contributing its small gleam to the whole, until the whole becomes something almost incandescent, something you can see from Earth with your naked eye on a clear night if you know where to look and the geometry is right. And yet, for all their grandeur, for all that planetary majesty, the rings are extraordinarily, almost impossibly thin. Imagine stretching a sheet of paper until it was wider than the distance from Earth to the Moon, and then imagine making it thinner than that same sheet of paper. The scale is roughly analogous to what Saturn has accomplished with its rings. They span an enormous distance in diameter, approximately 280,000 kilometers across, a disk so wide that if you placed it in our solar system centered on the Sun, it would reach more than halfway to Venus. And yet in thickness, this immense structure is only about 10 to 100 meters deep. In some places, less. In some places, the rings are thinner, relative to their diameter, than a single sheet of tissue paper would be relative to a football field. It is a geometry that the human mind resists, because we are used to things that have a certain proportion between their width and their height. And the rings of Saturn simply refuse to obey any intuition we have built up about how large things are shaped. When Voyager 1 arrived and began sending back its images, what it revealed was not the simple ring structure that earlier telescopes had suggested. Even Earth-based astronomers had identified by then that there were separate rings, labeled with letters of the alphabet, the A ring, the B ring, the C ring, each one slightly different in brightness and composition, separated by gaps where the ice was thin or absent. The most famous of these gaps, the Cassini division, had been known since the 17th century, a dark band between the bright outer rings and the brighter inner ones, named for Giovanni Cassini, who spotted it in 1675. But Voyager revealed that even this simple picture was breathtakingly incomplete. What Voyager saw was not a few rings separated by a few gaps. What Voyager saw was thousands of individual ringlets, each one a separate narrow band of ice particles, each one shaped and maintained and continuously herded into shape by the complex gravitational dynamics of Saturn's many moons, by resonances and perturbations, and the patient, invisible work of orbital mechanics playing out over millions of years. The rings were not simple. They were intricate. They were structured. They were almost impossibly organized, like the rings of a tree seen under a microscope, revealing a history of every winter and every summer. Except here, the history was written in orbital mechanics and frozen water and time scales that make human civilization seem like a brief afternoon nap. Some ringlets were braided around each other, twisted into rope-like structures that seemed to defy the physics of how things in orbit ought to behave. These braided rings, found in the narrow F ring just outside the main ring system, were eventually explained by the gravitational influence of two small moons, Prometheus and Pandora. Shepherding moons that orbit just inside and outside the F ring, their gravity nudging and pinching the ice particles back into line whenever they drift too far, keeping the ring narrow, keeping it contained, like two careful hands quietly shaping clay on a slow wheel. Voyager didn't just photograph these structures, it gave us the beginning of an explanation for them, which is something even more remarkable. There were also spokes, dark radial features that spread across the rings like the spokes of a wheel, appearing and disappearing over time, rotating with the rings and yet not behaving quite as orbiting particles should. These spokes puzzled scientists deeply, because if you are a particle in orbit around a planet, you orbit at a speed determined by your distance from the planet. Particles closer to Saturn orbit faster, particles farther away orbit more slowly, and so features that extend radially outward should be sheared apart by these different orbital speeds almost immediately. The spokes should not exist, and yet they did. They were there in Voyager's images, ghostly and enigmatic, and it took years of careful work to suggest that they might be caused by electrically charged dust particles, lifted briefly off the ring surface by electrostatic forces, floating above the plane of the rings like a temporary levitation, rotating not with the independent orbital motion of each particle, but with the planet's magnetic field instead. The rings, it turned out, were not merely mechanical. They were electromagnetic. They were, in some subtle sense, connected to Saturn's own magnetic heartbeat. All of this Voyager gave us, patient and methodical and endlessly surprising. This small machine that had been launched 3 years before from a Florida launch pad. Assembled by human hands from copper and silicon and glass, now floating in the cold dark of the outer solar system, taking pictures of things that had never been seen up close by human eyes. There is something deeply moving about that, if you let yourself sit with it quietly for a moment. The care that went into building Voyager. All of those engineers and scientists who spent years of their lives making sure the cameras would work, making sure the transmitters would transmit, making sure that when the moment came and the spacecraft swept past Saturn's rings in November 1980, the cameras would open their electronic eyes and see, and the seeing would be worth the long wait of the journey. Beyond the rings, Voyager's instruments turned their attention towards Saturn's many moons, and among them one stood out immediately. Not because it was the closest or the brightest or the most geometrically perfect, but because it was shrouded. Titan, Saturn's largest moon, wore a thick blanket of atmosphere, a dense orange haze that obscured its surface completely from Voyager's cameras, hiding whatever lay beneath behind curtains of orange photochemical smog. But what the cameras couldn't see, other instruments could begin to sense. Titan has an atmosphere denser than Earth's, composed primarily of nitrogen, the same gas that makes up most of the air you are breathing right now as you rest. As your body slows and your thoughts loosen and the day begins to blur softly at its edges, nitrogen, the most ordinary and abundant component of terrestrial air, here wrapped around an alien moon in such quantities that standing on Titan's surface, if you could somehow be transported there, you would feel the air pressing against you with more weight than Earth's own atmosphere presses against you now. And beneath those orange clouds and thick nitrogen skies, on Titan's frigid surface, there are lakes, not lakes of water, not the kind of lakes you might walk beside on a summer evening, watching the light break into gold coins on the surface. These are lakes of liquid methane, natural gas in liquid form, pooled in Titan's ancient basins, fed by methane rain falling from methane clouds in a slow orange drizzle, running down methane rivers into methane seas that stretch for hundreds of kilometers beneath skies the color of a bruised peach. The temperatures there are so cold, around minus 179 degrees Celsius, that water ice is as hard as granite, forming the bedrock of Titan's landscape. But methane, which freezes at even colder temperatures, flows freely, and it has shaped Titan's surface in patterns that look eerily, uncannily familiar to Earth-trained eyes. River deltas, shorelines, wave patterns, the geography of liquid, the patient work of fluid over time, just in a chemistry that is nothing like what we know at home. Voyager could only hint at all of this. It couldn't see through Titan's clouds. It couldn't peer down at those methane lakes. That would require another mission, another spacecraft, another generation of patient scientists sending another machine into the dark. But Voyager gave us the tantalizing outline of what was there, the thick atmosphere, the complex chemistry, the sense of a world that was not empty, not dead, not simple. Even if it was cold and strange and wrapped in an orange mystery, it gave us, again, the question, the most valuable thing any explorer can leave behind. And so as Voyager swept past Titan and the rings and the great golden sphere of Saturn itself, as its cameras caught those extraordinary images of thousands of ringlets glowing in the soft and distant sunlight, as the data streamed back across hundreds of millions of kilometers of empty space to the dishes waiting patiently on Earth, there was a kind of quiet triumph in the signal, in the steady, faithful pulse of information traveling at the speed of light across an almost incomprehensible distance to be caught and decoded and transformed back into images of things no human being had ever seen before. There was wonder in it. There was something that deserves to be called gratitude, though it is not entirely clear who to be grateful to, perhaps just to the universe for being so inexhaustibly rich, so full of things worth looking at. And those rings, which from Earth had always looked solid and still, revealed themselves to Voyager's cameras as something alive and breathing. Each icy fragment tumbling in slow, luminous circles like snowflakes caught in, and those rings, which from Earth had always looked solid and still, revealed themselves to Voyager's cameras as something alive and breathing, each icy fragment tumbling in slow, luminous circles like snowflakes caught in a wind so ancient it had been blowing since before our sun had finished learning how to burn. Each particle carried its own small orbit, its own private rhythm, and together they formed something that was neither solid nor empty, but somewhere tenderly in between. A kind of celestial lace spun from water and time. Voyager watched all of this with its quiet instruments, recording, measuring, remembering on behalf of a civilization still wrapped in the warm atmosphere of a small blue world it was already beginning to leave very far behind. And then, as all meetings must, this one ended. The gravitational conversation between Saturn and Voyager reached its natural conclusion, and in the language of physics, what happened next was both precise and beautiful. Saturn's enormous gravity, rather than pulling Voyager down and holding it, acted instead like a hand pressing firmly against the spacecraft's trajectory, bending it, redirecting it, sending it not forward along the flat plane, where the planets all swim in their ancient circular processions, but upward, northward, angled away from the ecliptic plane, like a stone skipped off a still pond and launched suddenly into the air. This was not an accident. It was, in a way, Saturn's farewell gift. The ringed planet had done what Jupiter could not, had sent Voyager on a path that arced up and away from the orderly solar neighborhood into a region that had no roads, no landmarks, no previous visitors, no name that meant anything except darkness and distance and the slow diminishing of everything familiar. But that departure also carried a quiet consequence, one that the scientists understood even as they celebrated the Saturn encounter from their crowded rooms at the Jet Propulsion Laboratory. By bending Voyager northward out of the ecliptic plane, Saturn had sealed a door. There would be no Uranus. There would be no Neptune. Not for this spacecraft, not on this journey. Those distant blue worlds would have to wait for another mission, another day, another set of carefully calculated trajectories. Voyager 1 had given itself entirely to Saturn, and Saturn, in its enormous indifferent generosity, had given Voyager to the void. Think for a moment about what that meant. Think about standing at the edge of a known map, where the careful lines of cartographers end and the parchment simply runs out, and taking one more step anyway. This is what Voyager was doing. Every kilometer it traveled beyond Saturn was a kilometer into territory that was, in the truest possible sense, unknown. In 1980, the vast region beyond the ringed planet was not merely unexplored in the way that a forest might be unexplored, where you could at least imagine what you might find inside. It was unmapped in a more fundamental way. It was a darkness that science had not yet learned to describe, a region whose properties, whose boundaries, whose very nature were questions that had not yet found their answers. Voyager was not following a path. It was making one, leaving behind it the thinnest imaginable thread of radio signals for human ears to follow, like a traveler dropping breadcrumbs in a wood that had no end. And in that darkness, something changed about the light. You would not have noticed it suddenly. It would have been gradual, the way evening comes, the way a room grows dimmer so slowly that you only realize how dark it has become when you reach for something familiar and find you can no longer quite see it. But as Voyager moved beyond Saturn, the sunlight that had accompanied it all the way from Earth, that had grown thinner and more tired with each passing month and each additional billion kilometers, began to fade into something that could barely be called light at all. At Saturn's distance, the sun is already reduced to a bright star, brilliant still compared to anything else in the sky, but stripped of its warmth, stripped of its immediacy, stripped of the generous flooding radiance we feel when we step outside on a clear morning and lift our faces toward it. Beyond Saturn, even that was slipping away. This matters for a very practical reason. Here on Earth, and throughout the inner solar system, spacecraft have often carried solar panels, wide wings of photovoltaic cells that drink in sunlight and convert it into electricity, powering instruments and transmitters and all the small, careful mechanisms that keep a spacecraft alive and working. But sunlight follows what mathematicians call an inverse square law, which is a technical way of saying that it fades with distance far more quickly than simple intuition suggests. Double your distance from the sun, and the light you receive does not halve but quarters. Move twice as far again, and it quarters once more. By the time you reach Jupiter, solar panels are already struggling. By Saturn, they are nearly useless. Beyond Saturn, they would be nothing but dead weight, beautiful and silent decorations on a craft that had outrun the reach of our star's generosity. The engineers who built Voyager knew this. They planned for it with a kind of quiet foresight that is easy to overlook but remarkable to contemplate. Instead of solar panels, Voyager carried something else entirely. 3 small devices clustered together like a modest bouquet called radioisotope thermoelectric generators. The name is long and technical and does not sound particularly poetic, but what these generators do is, in its own way, a kind of miracle made of physics. They contain a fuel called plutonium-238, a material that is not the kind of plutonium associated with weapons or reactors or any of the more alarming chapters of nuclear history. Plutonium-238 is calmer than that, gentler in its own way, a material that decays slowly and steadily, releasing heat as it does so. The way a stone warmed by the afternoon sun releases its warmth slowly back into a cooling evening long after the light has gone. That heat, generated by the quiet disintegration of atoms following their own ancient internal schedule, flows through the thermoelectric generators and emerges as electricity. Not a great deal of electricity, not enough to run a city or even a small building, but enough for Voyager, enough to power its instruments and keep its transmitter humming and hold its antenna aimed patiently at the small, bright dot of home. It is one of the most intimate images in all of space exploration, perhaps. This idea of a spacecraft sustained not by the light of its parent star, but by the warmth of its own carefully packed fuel. A traveler carrying its own small hearth into the dark, the way someone walking through a cold night might carry a lantern not to light the road, which stretches too far to illuminate, but simply to stay warm enough to keep walking. By the time Voyager crossed into this outer darkness, this territory beyond Saturn that had never been traveled, Earth was already approximately 1.5 billion kilometers behind it. 1.5 billion kilometers. Let that number drift through your mind the way music drifts through a quiet house, without trying to hold it entirely, just letting it settle into whatever space it finds. 1.5 billion kilometers. If you were to drive there at highway speed, without stopping, without sleeping, the journey would take more than 17,000 years. If you were to walk, the number becomes something that language barely has the tools to carry. And yet this was already behind Voyager, already the measured distance between the spacecraft and the world where it had been built by human hands and launched from a Florida morning by a column of controlled fire. Earth had become a memory measured in light minutes, and those light minutes were slowly, inexorably becoming light hours. There is something deeply peaceful about imagining this, even as it contains within it a kind of immensity that the mind cannot fully hold. Voyager was alone in a way that nothing human had ever been alone before. Not the solitude of a room to yourself, or the solitude of a mountain trail walked in early morning, or even the solitude of an ocean crossing far from any land. Those kinds of aloneness still exist within the warm embrace of an atmosphere, within the gravitational certainty of a world beneath your feet, within the reach of a sky that connects you to every other thing living under it. Voyager's solitude was different in kind, not just in degree. It was surrounded on all sides by a vacuum so complete and so cold that the concept of surrounding almost loses its meaning. There was no up and no down in any felt sense. There was no wind, no weather, no sound. There was only the spacecraft itself and the mathematics of its motion and the thread of radio waves it sent homeward at the speed of light, taking longer and longer to arrive. And yet for all of that solitude, Voyager was not entirely without company. It carried with it a kind of presence, the slow decay of its nuclear fuel, that pulse of warmth generated by plutonium atoms following their half-life toward transformation. There is something deeply calming about this if you let yourself sit with it. Radioactive decay is one of the most regular processes in all of nature, more reliable than clockwork, immune to temperature and pressure and the vagaries of environment. Plutonium-238 has a half-life of roughly 88 years, meaning that every 88 years, half of what remains will have converted itself into heat and then into the gentler element that follows it in the long sequence of nuclear transformation. Voyager's generators were designed around this constancy, this absolute predictability. In a universe that can feel chaotic and uncertain, here was a power source built from the most reliable thing imaginable, the unchanging rhythm of atomic physics, ticking away in the dark like the slowest and most faithful of heartbeats. The scientists who tracked Voyager from Earth during those early days beyond Saturn must have felt something that is difficult to name precisely. Triumph, certainly, because the Saturn encounter had exceeded almost every expectation, had returned images and data that would fill scientific journals and reshape textbooks for years. But also something more contemplative, something quieter and harder to articulate. They were watching a machine they had made depart from the known world entirely, venturing into a region where their models and their predictions became increasingly uncertain, where even their instruments for tracking the spacecraft had to be the most sensitive radio receivers ever built, straining to hear a signal that by the time it arrived was fainter than almost anything the universe produces. To listen for Voyager beyond Saturn required the full attention of the largest antenna arrays on Earth. Great dishes pointed at the sky like cupped hands raised in hope. What waited out there in that unmapped darkness was not nothing. The scientists suspected that they knew that the solar wind, that constant breath of charged particles streaming outward from the sun, must eventually meet the interstellar medium, the material that fills the spaces between stars. They knew there had to be a boundary somewhere, a place where the sun's influence finally faltered and something else began. But where exactly that boundary was, what it looked like, what it felt like in terms of magnetic fields and particle densities and temperatures, these were open questions in 1980. Questions that only something like Voyager could eventually answer by traveling there, by crossing that threshold, by becoming the first human artifact to feel the interstellar wind on its instruments. But that was far away still. In those early days beyond Saturn, Voyager was simply moving, constant and unhurried, committed entirely to its outward trajectory, its nuclear warmth keeping its instruments alive. Its antenna aimed homeward, its cameras still open to the dark, even as the dark deepened around it, into something that had very little left to photograph. The planets were behind it, the familiar patterns of the solar system, the neat procession of worlds that humans had been watching and naming and mythologizing since they first lay on their backs in the dark and looked up. All of that was receding like the memory of a dream, still present in sensation, but growing harder to hold in detail. In the silence of those first weeks and months beyond Saturn, there was a kind of stillness that felt almost sacred. Not the stillness of absence, but the stillness of arrival, of settling, of a journey finding its true shape after all the dramatic encounters and gravitational conversations were done. Voyager was not racing now. It was not performing. It was simply going, with a steadiness that had something almost meditative about it. And behind it, the solar system curved away into its own warm brightness, while ahead of it the darkness deepened, into distances that made the distances already traveled feel small and almost intimate, with Saturn's golden light fading slowly behind it. Voyager crossed into a part of space where no human-made object had ever traveled, powered only by the slow, warm breath of decaying atoms. Drifting outward through a darkness so complete, and so with Saturn's golden light fading slowly behind it, Voyager crossed into a part of space where no human-made object had ever traveled, powered only by the slow, warm breath of decaying atoms, drifting outward through a darkness so complete and so ancient that the very concept of distance began to lose its ordinary meaning. There were no landmarks here, no nearby stars to cast shadows, no planets to catch the light and hold it warmly. There was only the slow, patient dark, and within it, this small and faithful traveler, still listening, still sending its quiet signals home across a widening gulf that grew larger with every passing hour, every passing year. It had been traveling for more than a decade by then. Launched in the golden summer of 1977, Voyager 1 had swept past Jupiter and Saturn, had bent its course around those great giants, had gathered their gravity like a gift and used it to fling itself outward with even greater speed, a stone released from a cosmic sling. It had seen things no human eye had ever seen, had sent home images so strange and so beautiful that scientists had wept at their desks, had stood in corridors and stared at printouts with expressions that had no proper name. And now, in the quiet of early 1990, it was farther from home than anything we had ever made. 6 billion kilometers. Let that number rest in you for a moment, the way you might let a stone rest in your open palm, feeling its weight, its realness. 6 billion kilometers. The light from Earth, traveling at the fastest speed that anything in this universe can travel, would take more than 5.5 hours to reach Voyager where it floated in that outer dark. Our radio signals, our little whispered messages sent racing across the void, took the same 5.5 hours to arrive and another 5.5 hours to carry any reply back home. A conversation with something 11 hours wide. It requires a particular kind of patience, a particular kind of faith to speak across a silence that vast. And yet, someone had the idea to look back. It was Carl Sagan, that great tender poet of the cosmos, who made the request. He had been one of the scientists who helped design Voyager's mission all those years before, and as 1990 approached, as the spacecraft drifted toward the very edges of our solar family, He recognized that a rare and fleeting opportunity was almost upon them. Voyager 1 was now so far out, so high above the plane of our solar system, that if you turned its cameras around and aimed them inward toward the sun, you could, perhaps, capture all the planets in a single sweeping portrait. A family photograph of the solar system taken from the outside, from the cold and patient dark beyond. There was resistance at first. Some engineers worried about the sun's light damaging the cameras. Some scientists felt the photographs would have little scientific value, that the planets would be too small and too distant to reveal anything useful to planetary science. But Carl Sagan pressed gently and persistently, the way he always did, not with arrogance, but with that particular kind of quiet insistence that comes from understanding something deeply beautiful and wanting to preserve it before the moment passes forever. And in the end, the decision was made. On Valentine's Day, February 14, 1990, mission controllers sent the command, a pulse of light racing outward at the speed of light itself, traveling 5.5 hours through the dark, before finally reaching Voyager and whispering, "Gently, turn around." Think about what that moment must have felt like. This spacecraft, which had been moving steadily outward for 12.5 years, which had been trained for so long on the wonders ahead of it, which had faced always outward into the unknown, now slowly, carefully, turned its cameras back toward home. It was like watching someone pause on a long journey and turn, just for a moment, to look back at the place they came from. The soft lights of a childhood home glowing in the evening distance. Voyager turned, its cameras open, and over the course of several months, it assembled a mosaic of 60 photographs, a sweeping panorama of our solar system seen from the outside. In this portrait, you could find Jupiter, a pale dot of amber, Saturn, barely visible but there, Uranus and Neptune, blurred smudges against the dark, and Earth, our Earth, the planet where every human being who has ever lived was born and breathed and loved and died. Our world appeared as a single pixel, one tiny point of pale blue light, smaller than the smallest thing your eye can comfortably hold, suspended in a scattered ray of sunlight that fell across the camera's field of view and caught it like a mote of dust caught drifting through an afternoon window, a pale blue dot. Those 3 words became something more than a description. They became a kind of prayer, a kind of medicine, something you could hold in the chest and feel settle there, changing the way you breathed, the way you stood in relation to everything around you. A pale blue dot, Earth from 6 billion kilometers away, is not a world. It is not a place with countries or mountains or oceans deep enough to lose yourself in. It is not a place where wars are fought or borders drawn or empires built. It is a point of light so small it nearly disappears, suspended in a sunbeam, easy to miss if you were not looking carefully, easy to overlook entirely against the vast and indifferent dark that surrounds it on all sides. And Voyager's cameras, having captured this portrait, having fulfilled what would be their final duty to the human story, were then switched off forever. There was no ceremony for this, no countdown, no grand announcement. It was a quiet and practical decision, made to conserve what little power remained in those decaying atoms. To preserve Voyager's ability to keep transmitting its scientific data as it continued outward into the interstellar dark. The cameras had done their work. They had shown us Jupiter's storm eye, Saturn's impossible rings, the cracked and sullen surface of Io, the smooth and mysterious face of Europa. And now in their last act, they had shown us ourselves. They had shown us home, and then they closed, like eyes easing gently shut at the end of a very long and beautiful day. It was Carl Sagan who found the words for what this image meant, and if you have ever heard his voice, you know that it was a voice made for exactly this kind of moment, warm and unhurried, carrying within it a deep and unironic sense of wonder, the voice of someone who had spent a lifetime looking up and had never once grown tired of the view. He wrote a meditation on the pale blue dot that has since become one of the most famous pieces of scientific writing ever composed. Read and reread and whispered and memorized by people across decades and languages and circumstances, people who have found in it something that no strictly technical description of the cosmos could ever quite provide. He wrote about motes of dust suspended in a sunbeam. He wrote about the rivers of blood that have been shed throughout history by generals and emperors so that they might briefly command a fraction of a pale blue dot. He wrote about every hunter and forager who ever lived on this world, every hero and coward, every creator and destroyer of civilizations, every king and peasant. Every young couple in love who ever stood beneath a summer sky and felt, for one trembling moment, as though the universe had been made for them alone. All of them, every single human being who ever drew breath on this planet, all their joy and suffering, all their genius and foolishness, all their tenderness and cruelty, all of it contained, when viewed from Voyager's distance, in that single point of light. There is something in that fact that works on the mind very slowly, the way cold water seeps through soil, the way a piece of music you heard once in childhood returns to you decades later without warning, and opens something you had forgotten was there. It does not strike you all at once. It settles in quietly, over time, and changes things from the inside. Because when you hold that image in your mind, when you really try to feel the distance and the darkness and the smallness of that pale blue point against the cosmic dark, something shifts. The ordinary sorrows of an ordinary day, the small humiliations and frustrations and anxieties that gather like weather in the mind, they do not disappear exactly, but they are seen differently, held at a different angle, the way you might hold a stone at a different angle in the light and suddenly see colors in it you had not noticed before. The universe is not small, and we are, in one very true and measurable sense, almost incomprehensibly tiny within it. But here's the thing that Carl Sagan understood, the thing that his voice carried so gently in its warmth, the thing that the pale blue dot teaches if you let it. Our smallness is not a reason for despair. It is, if you are willing to receive it as such, an invitation to tenderness. When you understand that this small blue mote is the only home we have ever known, that there is no other world waiting for us just beyond the edge of our troubles, that every person you have ever loved or argued with or passed on a street and never thought of again has lived and will live on this same small point of light, then the distance between us shrinks. The differences that seem so vast and insurmountable from inside them become, from the right distance, almost invisible. What remains is the shared fact of being here, the shared improbability of this small lit world in the enormous dark. Voyager continued on after that, of course. The cameras closed, but the spacecraft did not stop. It kept moving, kept drifting outward along the invisible curve of its trajectory, kept listening for the signals we sent it and sending its own quiet signals back. There was still science to do, still data to gather from the instruments that remained powered and active. The solar wind grew thinner around it. The sun's influence, which had shaped space itself in a vast, invisible bubble called the heliosphere, began to weaken. Voyager moved toward the edge of that bubble, toward the boundary where the sun's domain gives way to something older and larger and more mysterious still, the true interstellar space, the dark between the stars. But for now, in the stillness of this telling, let us stay for a little while with the image. Let us stay with that pale blue dot, that single pixel of light caught in a scattered sunbeam 60 photographs and 6 billion kilometers from home. Let us stay with the quiet miracle of it, the fact that we turned and looked, that we had the wisdom and the poetry in us to want to see ourselves from the outside, to hold the image of our home in our hands like something fragile and irreplaceable. Let us stay with the feeling it produces, that specific mixture of smallness and tenderness, and something that is not quite sadness but lives near it. The feeling of understanding for one clear and unclouded moment, exactly where and what you are. Outside your window right now, if you were to go and stand beneath the night sky and look up through whatever light remains, through the amber glow of streetlights or the deep country dark, you would be looking at the same stars that Voyager drifted among, the same ancient dark, the same incomprehensible distances. And somewhere out there, still moving, still listening, still sending home its threadbare signal, Voyager carries a record of who we were when we made it. A golden disc pressed with music and greetings and the sounds of a living world. It carries us outward into a dark it will travel, for longer than human civilization has yet existed, and the Earth it left behind. The pale blue dot it photographed and then could no longer see, goes on turning, slow and faithful, carrying all of us together through the same ancient dark. And in that single pixel, no bigger than a mote of dust caught in a sunbeam, every mountain and ocean and city and sleeping child lay folded into one small point of light, and Carl Sagan's voice, gentle and unhurried, reminded us that on this and in that single pixel, no bigger than a mote of dust caught in a sunbeam, every mountain and ocean and city and sleeping child lay folded into one small point of light, and Carl Sagan's voice, gentle and unhurried, reminded us that on this pale blue dot, suspended in a sunbeam, we have built everything we have ever known. And yet, even as we hold that image close, even as we let its smallness settle into our bones like something both humbling and tender, the sun continues its great work. Not just with light and warmth, not just with the gravity that keeps us circling in our faithful orbit, but with something far less visible, far less understood. Something that stretches out in every direction, like the walls of an enormous, invisible room. Imagine, if you will, that you are standing somewhere very high, high enough that the air has grown thin and the stars no longer flicker, but simply burn, steady and cold and very far away. The darkness around you is vast enough to be almost physical, almost something you could press your palm against and feel the weight of. And in that darkness, you begin to understand that the space through which our solar system moves is not empty. It is full of something ancient and everywhere. A slow breath of particles and magnetic fields exhaled by other stars, the accumulated whisper of the galaxy itself. This is the interstellar medium, the great sea that our sun and all its planets are sailing through. And to sail through it, the sun does something remarkable. It breathes out every second. From its surface and its corona and its outermost regions, the sun releases a stream of charged particles, mostly electrons and protons, moving at speeds between 300 and 800 kilometers per second. This is the solar wind, a river of energy and matter flowing outward in all directions, relentless and warm in the way that something ancient and generous can be warm even at tremendous distances. And this solar wind does not simply dissipate. It pushes, it carves out a space. It inflates a bubble around our entire solar system. A vast, invisible, almost incomprehensible shelter that astronomers call the heliosphere. The heliosphere, even the word has a kind of breath in it, a softness at the edges. It is the sun's great invisible bubble, and it extends outward from the sun in all directions to a distance of roughly 100 astronomical units. 1 astronomical unit is the distance from the Earth to the sun, about 150 million kilometers, a distance so large that light, traveling at nearly 300,000 kilometers per second, takes about 8 minutes to cross it, and the heliosphere extends 100 times further than that. 100 times the distance from here to the sun, stretched out in all directions, a bubble of solar influence enclosing everything we have ever sent into space, every probe, every lander, every satellite, every small human thing flung outward in curiosity and hope. To say the heliosphere is large is almost meaningless. The way it becomes meaningless to say the ocean is wet or the sky is high. The numbers are there, but they do not quite reach you until you sit with them quietly for a moment, in the dark, letting the scales settle like snow, softly and without rush. Neptune, the outermost of our 8 planets, orbits the sun at a distance of about 30 astronomical units. The heliosphere continues outward for another 70 astronomical units beyond that. The Kuiper belt, filled with icy bodies and ancient remnants of the solar system's formation, lies entirely within this bubble. Even the inner reaches of the Oort cloud, that vast spherical shell of frozen objects orbiting at almost unthinkable distances, rests inside the heliosphere's embrace. All of it, all of this incredible architecture of ice and rock and gravity and light, wrapped in a single breathing bubble of solar wind. And as you drift towards sleep, perhaps you can picture it, not from the inside where we live, but from somewhere far above, the way you might see a soap bubble glowing in afternoon light, iridescent and trembling, holding everything precious within its thin and radiant membrane. Our solar system, seen from a great enough distance, would look something like that. A faint, elongated sphere of warmth and electromagnetic activity, moving slowly through the cold dark of the galaxy, leaving behind it a long, comet-like tail called the heliotail. The wake of the sun's passage through interstellar space. From out there, from far enough away, we would be a small glowing thing, a lantern being carried through a vast and sleeping forest. But what happens at the edges of this bubble? What happens when the solar wind, having traveled 100 astronomical units from its source, begins to meet resistance? This is where the story grows quieter and more intricate, where the science becomes something almost meditative, a series of invisible thresholds crossed in silence and profound cold. The solar wind travels outward at supersonic speeds. For most of the heliosphere's interior, it moves faster than the speed of sound in that medium, faster than any disturbance it creates can propagate ahead of it. But at some point, somewhere around 80 to 100 astronomical units from the sun, depending on the direction and the current state of solar activity, the solar wind begins to encounter the pressure of the interstellar medium pushing back. And when a supersonic flow meets resistance, something specific and dramatic happens. It slows down suddenly, almost shockingly, dropping from supersonic to subsonic speeds across a relatively thin region. This region is called the termination shock. The termination shock. There is something almost poetic about that name, as though the sun's long exhale finally meets the wall of the world and trembles. Across the termination shock, the solar wind slows, compresses, heats, and becomes turbulent, its smooth outward flow disrupted and transformed. For decades, this boundary existed only in theory, in equations and models, and the careful imaginations of planetary scientists. And then, on a date that will be quietly remarkable for as long as there are people to remember it, on the 16th of December in the year 2004, a small spacecraft named Voyager 1 crossed the termination shock. Voyager 1. Let us hold that name gently for a moment. Launched in September of 1977, more than 4 decades before anyone reading these words was likely thinking about it. Voyager 1 was built to explore the outer planets. It flew past Jupiter in 1979 and Saturn in 1980, sending back images of a beauty and strangeness that still take the breath away. And then it kept going. It kept going long after its primary mission was complete. Kept going because the scientists and engineers who loved it pointed it outward and said, "Go. See what is there? Tell us what you find at the edge of everything we know." By 2004, Voyager 1 had been traveling through space for 27 years. It was moving at speeds of about 17 kilometers per second relative to the Sun. And on that December day, its instruments registered something, a change in the particle density around it, a shift in the magnetic field, the unmistakable signature of the solar wind slowing and thickening and pressing together. Voyager 1 had reached the termination shock, and it crossed through, and it entered the region beyond. Beyond the termination shock lies the heliosheath. This is a thick, tumultuous region like the inside of a great storm that has been compressed and slowed, but not yet resolved, not yet calmed. Here the solar wind, no longer moving in smooth radial streams outward from the sun, churns and roils and folds back on itself, caught between its own outward momentum and the pressure of the interstellar gas pushing in. The heliosheath is estimated to be somewhere between 25 and 50 astronomical units thick, depending on where you measure it. A vast transitional zone between the sun's dominion and the territory that belongs to no star in particular. Voyager 1 spent years crossing the heliosheath, its instruments sending back data that puzzled and fascinated, and sometimes surprised the scientists waiting on Earth. The magnetic field here behaved strangely. The particle counts fluctuated. The environment was not what had been expected. Not exactly, not neatly, because nature rarely is. The heliosheath is a complicated place, as complicated as any borderland, any region where two great forces are meeting and negotiating and pushing against each other in ways that take time and careful attention to understand. And still Voyager kept going. Still it pressed outward through that churning region, small and patient and warm with the memory of the sun's original acceleration, carrying its golden record and its fading signal, and the accumulated weight of human curiosity into distances that have no everyday equivalent. No frame of reference drawn from the landscapes we walk through and the skies we know. And then came the outermost boundary of all, the heliopause. This is the true edge of the sun's influence, the place where the solar wind pressure and the interstellar gas pressure finally reach equilibrium. where the two invisible forces meet and hold each other perfectly in balance. On one side of the heliopause, the particles are solar, born from our star, carrying within them something of the chemistry and the energy of the sun that warms our days and brightens our skies. On the other side, the particles are interstellar, older and more diffuse, the breath of dead stars and nebulae and processes that happened long before our sun was born. The heliopause is the membrane between our solar family and everything else. It is, in the most precise sense, the edge of home. For years, the scientists watching Voyager's data waited for the signs. They debated what those signs would look like. They argued about what threshold readings would definitively confirm that the probe had crossed into interstellar space, beyond the heliopause, beyond the last reach of our sun's persistent breath. And then the data came. In August of 2012, Voyager 1 crossed the heliopause and became the first human-made object to enter interstellar space. Think of that as you let your breathing slow and your thoughts grow softer, and the edges of wakefulness begin to blur. A machine built by human hands, assembled in a factory somewhere in California in the 1970s, guided by engineers working with the computing power of pocket calculators by today's standards, traveling for 35 years through the darkness, crossed the edge of our solar system and entered the space between the stars, not the space between the planets, not the space between the sun and the outer planets, the space between stars, the true deep dark, the oldest kind of quiet there is. Voyager 1 is still out there, right now, as you listen to these words, as your body settles into sleep, and your breath grows long, and even that small spacecraft is moving through interstellar space. Somewhere around 22 to 23 billion kilometers from the sun, a distance so large it takes the radio signals it sends back to Earth more than 20 hours to arrive, traveling at the speed of light and still taking 20 hours. And yet we receive them, and yet the scientists listen. And yet we know where it is, and what it is measuring, and what the interstellar medium feels like just beyond the edge of home. There is something deeply settling about this, if you let it be. Not in the way that small, familiar things are settling, not in the way of a warm blanket or a closed door on a winter night, but in a larger, slower way. The way that vast things can be calming when you stop trying to hold them and simply let them be vast. The heliosphere is enormous beyond ordinary comprehension, and yet it is finite. It has a shape, it has an edge, and that edge was crossed by something we made, by something we sent, by something that carried, in a very real sense, the curiosity and the reach and the extraordinary persistence of every scientist and engineer who stayed up late and solved equations and refused to stop asking what is out there. What is at the edge? What comes after? What comes after the heliopause is interstellar space. Cool, ancient, filled with a kind of matter and radiation that is genuinely different from what exists inside the heliosphere. Voyager's instruments registered the change clearly. The density of plasma increased. The direction of the magnetic field shifted. The energetic particles changed in character and origin. The sun's long breath was gone, and in its place was something else, something that belongs to the galaxy rather than to any single star. It is strange and wonderful to consider that the space between us and the nearest other star is not empty, but filled with this interstellar medium, this slow and ancient gas that drifts between stellar systems like fog between mountains. And somewhere in that fog, still moving at 17 kilometers per second, Still sending its faint signal home, Voyager 1 continues its journey. It will not reach the nearest star system for tens of thousands of years, but it is there. It is out there right now, in the dark, in the cold, in the extraordinary quiet of a place no human being has ever visited and perhaps never will. And that is not a sad thought if you hold it correctly. It is a vast thought. Certainly, it is an overwhelming thought, in the way that standing beneath a sky so clear and so full of stars that it presses down on you is overwhelming, not with dread, but with a kind of exquisite fullness. The feeling that the universe is more than you can hold, and that this is precisely as it should be. There is a comfort in things being larger than comprehension. There is rest in knowing that the universe does not require you to understand it fully. It asks only that you look, occasionally, and feel the particular quality of wonder that comes from the looking. The heliosphere breathes with the sun's activity. During periods of high solar activity, the bubble expands slightly, pushed outward by stronger solar winds. During quieter periods, it contracts a little as the interstellar gas presses in more successfully. The termination shock moves inward and outward accordingly, a boundary that is never quite still, never quite settled, always somewhere in negotiation between the sun's energy and the galaxy's ancient pressure. The whole thing is alive in its way, breathing gently, adjusting, finding its balance in the slow rhythm of a star's 11-year cycle of activity. The heliosheath roils and turns within that living boundary, turbulent and strange, a place where our star's last influence churns before giving out entirely. And then at last, calmly and without drama, quietly and with a finality that is more like a soft door closing than anything sudden or violent. At the heliopause, the solar wind simply stopped, as though the sun had exhaled its last long breath, and Voyager passed through the edge of that invisible membrane into something older and quieter than anything our star had ever at the heliopause. The solar wind simply stopped as though the sun had exhaled its last long breath, and Voyager passed through the edge of that invisible membrane into something older and quieter than anything our star had ever known or shaped or touched. And what Voyager found on the other side was not emptiness, not silence in the way we sometimes imagine silence, a perfect absence, a vacuum scrubbed clean of all presence. What it found was something far more ancient, far more textured, far more full of soft and patient substance than any of us might have expected when we first began to dream of sending a small golden messenger beyond the only sky our civilization had ever truly called its own. Interstellar space is not empty. That is perhaps the most important thing to understand as we float here together in this quiet hour, letting our breathing slow, letting the weight of the day dissolve like mist above a still lake at dawn. The space between the stars, that vast oceanic darkness that stretches between our sun and the next nearest flame, is not a void. It is a medium, a presence, something that drifts and fills and threads itself through all the space between stellar fires, carrying within it the memory of events so ancient and so violent that our human minds can only hold them gently, the way you might hold a very old and fragile thing, carefully, softly, with full awareness of its age. The interstellar medium, as scientists call it, is woven from low-density plasma, from gas and dust so thin and so diffuse that it would seem like nothing at all if you tried to gather it in your hands. And yet it is there. It is measurable. It has texture and temperature and magnetic personality. It carries cosmic rays, those high-energy particles flung outward from the violent deaths of stars far across the galaxy, supernovae that exploded perhaps millions of years ago, flinging their energetic remnants in all directions like ripples spreading from a stone dropped into the deepest and widest pool you can imagine. Those ripples are still traveling. They pass through interstellar space, still carrying the energy of their origin, still whispering of those ancient stellar fires that gave them birth. When Voyager 1 crossed the heliopause, the instruments aboard registered something very specific and very telling. The density of plasma around the spacecraft increased, not dramatically. Not in any way that would have felt sudden or harsh, but measurably, detectably, in a way that spoke volumes to the scientists watching from Earth. Inside the heliosphere, the solar wind had kept the interstellar plasma pressed back, held at a distance, like water held back from a harbor by a long and curved and invisible seawall. But once Voyager passed through that boundary, the interstellar plasma was present in a way it had not been before. Denser, different in composition, the signature of another kind of ocean entirely. One that does not belong to our sun, one that has its own slow currents and its own ancient chemistry and its own story to tell. It was this detection of increased plasma density that gave scientists the confirmation they had been waiting for. It was the moment they knew, with the particular quiet certainty that comes from real data speaking clearly, that Voyager 1 had indeed entered interstellar space. Not simply reached the edge, not simply grazed the boundary, but passed through, crossed over, become, in some beautiful and almost ceremonial sense, an interstellar object. A human-made thing drifting now in the space between the stars, carrying its golden record and its silent instruments, and the faint whisper of radio signals still winding their way back across the unimaginable distance to ears and receivers and minds waiting patiently on a small blue world. And then there were the magnetic fields, because even here, even in the deep interstellar ocean beyond the sun's influence, space is not magnetically neutral. The interstellar medium carries its own magnetic field lines, ancient threads of electromagnetic force that trace their own geometry through the dark, aligned differently from the magnetic fields generated by our sun, pointing in different directions, speaking a different magnetic language entirely. Voyager's instruments detected this shift directly. They measured the change in magnetic field orientation as the spacecraft moved from the sun's magnetically ordered domain into the interstellar medium's own quietly different arrangement. It was, in its way, like feeling the current change beneath you as you drift from one body of water into another, the same water in some sense, the same physical laws governing everything, and yet something different in the texture of what surrounds you, something that tells you wordlessly that you have passed from one realm into another. Think about floating on water, not swimming, not struggling, simply floating, eyes closed, the water supporting you completely, surrounding you, touching every part of you that it can reach. Now imagine that the water itself has a grain to it, a direction, the way wood has grain, or the way certain ancient fabrics have a warp, and a weft that you can feel if you press your fingers gently enough against them. That is something like what the interstellar medium is, a medium with structure, with direction, with magnetic personality and dusty breath, and the long, slow drift of plasma that has been moving through this darkness since before our solar system was born. The dust that drifts through interstellar space is made of remarkable things. carbon and silicates and iron, and the remnant molecules of stars that lived and died before our sun ever ignited. When you look at the night sky and see a haze of light along the Milky Way, much of what dims and softens that light is interstellar dust, tiny grains suspended in the medium, catching and scattering starlight the way smoke or fog catches the beams of a lamp. Voyager moves through this dusty, plasma-filled, magnetically threaded ocean now, and it has been doing so for years, accumulating time and distance in the patient way that only a thing moving through truly cosmic scales can accumulate them. And yet, here is something worth holding gently in your mind as you drift towards sleep. Despite everything, despite crossing the heliopause, despite entering interstellar space, despite the plasma shift and the magnetic reorientation and all those billions of kilometers now lying between Voyager and the sun that launched it, Voyager 1 is still, in the gravitational accounting of our solar system, gravitationally bound to the sun. The sun's gravity, that immense and patient force radiating outward in all directions from our star's enormous mass, does not simply stop at the heliopause. Gravity does not respect the boundaries that plasma and magnetic fields draw. It extends far, far beyond anything the solar wind could ever reach. And so Voyager, moving at its remarkable speed, is still technically held within the gravitational embrace of the sun, still technically a member of our solar family, even as it drifts through space that belongs to no star in particular. True gravitational escape, true departure from the sun's influence, lies tens of thousands of years in Voyager's future. Tens of thousands of years. Let that settle into you the way warmth settles into your body when you lie beneath a heavy blanket. Tens of thousands of years. Our civilization has existed for a tiny fraction of that time. The pyramids of ancient Egypt are perhaps 5,000 years old. The oldest written records our species has produced stretch back perhaps 6,000 years. And yet the timescale on which Voyager will finally, fully gravitationally break free from our sun is longer than all of recorded human history multiplied several times over. We sent something out into the cosmos, and it will be journeying, still technically tethered to us by the invisible thread of gravity, for longer than our civilizations have had language to describe the stars it travels toward. Voyager 1 is currently moving at approximately 17 kilometers per second. 17 kilometers per second. If you could move that fast across the surface of the Earth, you would circle our entire planet in under 40 minutes. You would lap the globe faster than most of us sleep through a single dream cycle. And yet, measured against the distances of interstellar space, 17 kilometers per second is a kind of exquisite patience. It is enormously fast by every human measure, and yet barely adrift against the scale of what lies between stars. The nearest star system to our own, the triple system anchored by Alpha Centauri, lies roughly 4 light-years away. At Voyager's current speed, it would take the spacecraft approximately 73,000 years to reach that distance if it were even headed in that direction, which it is not. It is aimed at a different part of the sky, drifting toward the constellation Ophiuchus, moving through an interstellar ocean so vast that our fastest human-made object, our greatest achievement in velocity, becomes something very close to stillness when held against the true scale of what surrounds it. And yet it moves, silently, continuously, without pause or hesitation. Voyager moves 17 kilometers every second, through plasma and dust and cosmic rays from long-dead stars. through magnetic field lines that are not our sun's own, through the interstellar medium that has been filling this space between stellar fires since the galaxy itself was young. It does not feel the cold because it has no nervous system to register temperature. It does not feel the loneliness because loneliness requires a mind that remembers company. It simply moves, carrying its golden record, carrying its silent instruments, carrying the accumulated intentions of every human being who ever looked at the night sky and wondered what might be found beyond the furthest edge of what we knew. The interstellar medium through which Voyager now drifts is not uniform. It has regions of differing density, clouds of gas that are slightly warmer or slightly cooler, variations in magnetic field strength, concentrations of dust and plasma that shift and change over the extraordinary timescales on which this ocean moves. Our solar system itself is currently passing through a region called the local interstellar cloud, a warm, low-density bubble of partially ionized hydrogen and helium that may surround us for another few thousand to tens of thousands of years before we drift into whatever neighboring structure comes next. Voyager is now ahead of us in that drift, exploring the texture of this cloud from the inside, sending back measurements that help us understand the very medium through which our entire solar system is sailing on its own long journey around the center of the Milky Way. There is something deeply calming about this thought. If you let it be, we are not fixed. Our sun is moving. Our entire solar system is moving. Sailing through the galaxy at roughly 230 kilometers per second, carrying all its planets and moons and comets and asteroids, and the tiny golden messenger we call Voyager through the interstellar medium like a ship on an ocean that has no shore we will ever reach in any lifetime we can conceive. Everything is in motion. Everything is drifting, and from within that drift, Voyager drifts a little further still, a small, bright point of human intention moving through an ancient, whispering, magnetically threaded, dusty, plasma-filled sea. The cosmic rays that Voyager encounters in the interstellar medium arrive from every direction, flung outward by supernovae across the galaxy. Some of them perhaps traveling for millions of years before they brushed against Voyager's instruments and registered in the data that wound its way home to Earth. They are the echoes of stellar deaths, the energetic remnants of moments of unimaginable violence, stars collapsing and exploding and scattering their substance across the galaxy, seeding the interstellar medium with the atoms and the energy that will eventually, in some other corner of the cosmos, perhaps coalesce into new stars and new planets and new forms of chemistry we cannot yet imagine. Voyager moves through these remnants the way you might move through the last fading ripples of a wave that broke on a distant shore long before you arrived. The energy is real. The history is real. But the event itself is so far removed in both time and space that it arrives to you as nothing more than a gentle undulation, a softness, a barely perceptible presence. Out here in the interstellar medium, time moves differently somehow. Or perhaps it is simply that the distances are so enormous that speed itself begins to feel like stillness. And Voyager drifts onward through a sea of ancient starlight and the faint whispered echoes of out here in the interstellar medium. Time moves differently somehow. Or perhaps it is simply that the distances are so enormous that speed itself begins to feel like stillness. And Voyager drifts onward through a sea of ancient starlight and the faint whispered echoes of supernovae that burned and faded long before our sun had even begun to stir from its own primordial cloud of gas and dust. And there is something deeply, quietly astonishing about that? Something that asks nothing of you except to lie still for a moment and let the scale of it settle gently over you, like a warm and weightless blanket pulled up around your shoulders on a cold and starry night. The instruments aboard Voyager 1 have been speaking to us for decades now, sending home their patient measurements, their careful readings of magnetic fields and particle densities and the strange, shifting boundary where our sun's influence finally gives way to the broader, older silence of interstellar space. But those instruments are powered by heat, by the slow decay of plutonium-238 in the spacecraft's radioisotope thermoelectric generators, and that heat has been fading, degree by degree, year by year. The way a fire fades, not dramatically, but gently. The embers growing quieter and dimmer through the long hours of a winter night. By around the year 2025, scientists expect that the power available to Voyager will no longer be sufficient to operate any of its scientific instruments at all. The last measurements will be taken. The last data will travel home across that extraordinary distance, arriving here at the speed of light, taking more than 20 hours to make that crossing. And then the instruments will go dark, one by one, each falling into its own kind of peaceful silence. But here's what I want you to hold gently in your mind as you settle deeper into the quiet. The going dark of those instruments is not an ending. It is not even close to an ending, because Voyager itself, the physical spacecraft, that golden disk-carrying, human-made piece of Earth launched into the cosmos in 1977, will continue. It will drift on through the dark, between the stars, not for years, not for centuries, but for billions of years, moving through a silence so complete and so vast that the word silence itself feels too small for it. There are no breaks out there. There is no friction in the interstellar medium substantial enough to slow a spacecraft meaningfully over the timescales we are talking about. Voyager will simply continue, a tiny bright artifact of a species that once stood on a small blue world and chose to reach outward into the unknown. 40,000 years from now, something extraordinary will happen, though there will be no one aboard to notice it, and the event itself will unfold in the slowest, most gradual of ways. In about 40,000 years, Voyager 1 will pass within approximately 1.6 light-years of a star called Gliese 445, a small reddish star located in the constellation Camelopardalis, which the ancient skywatchers named for the giraffe, that gentle, long-necked creature that reaches upward toward the leaves of the highest branches. Gliese 445 is not a star we talk about very often here on Earth. It is quiet and unassuming, a cool red dwarf burning steadily and patiently in its small corner of the galaxy. And in 40,000 years, it will be closer to us than it is today, moving toward our solar system through the gentle drift of stellar motion. And Voyager will drift past it, or near it, in the way that ships in the ancient world might drift past a distant island they never intended to visit, close enough to feel the faint gravitational whisper of its presence, close enough that if there were any eyes near that star to look, they might see, with instruments sensitive enough, a tiny glinting thing passing through the dark. 1.6 light-years is still an enormous distance. Light itself, the fastest thing in the universe, would take more than a year and a half to cross it. And yet, in the context of our galaxy, in the context of the hundreds of billions of stars scattered across the Milky Way alone, 1.6 light-years is a kind of neighborhood closeness, the sort of distance that reminds us how the universe, for all its staggering scale, sometimes brings things near to one another in its own slow and unhurried way. Voyager will not stop at Gliese 445. It will pass by, and then it will continue, pressing on through more thousands and millions and billions of years of patient, silent drifting. And here, perhaps, is the most quietly stunning thought of all, the one I want to offer you, softly as you breathe slowly and let your body grow heavier and more restful with each passing moment. The golden record, that gleaming copper disc plated in gold and etched with the sounds and images of Earth, with the music of Bach and Chuck Berry, with the sound of rain and the laughter of children, with the pulsar map that marks our location in the galaxy like a gentle cosmic greeting card. That record will very likely outlast the Earth itself. Not because Earth is fragile, not because our planet is in any immediate danger, but simply because the timescales involved in Voyager's journey through interstellar space are so vast that they encompass geological epochs and stellar lifetimes with the same ease that a long summer night encompasses both the last light of dusk and the first pale brightening of dawn. In roughly 5 billion years, our sun will have exhausted the hydrogen fuel in its core. It will begin to expand, slowly at first, and then with increasing momentum, swelling outward into what astronomers call a red giant. A star so large that it will likely engulf Mercury and Venus, and possibly Earth itself, or if not engulf, then at least render the surface of our planet molten and unrecognizable. The oceans boiled away, the atmosphere stripped, every trace of every city and every forest and every ocean trench transformed into something that would be unrecognizable to any eyes that had known Earth in its living blue-green prime. The continents will be gone. The songs will be gone. The languages and the photographs and the libraries and the long winding rivers will all be gone. But Voyager will still be drifting, somewhere out in the dark, beyond the reach of even a swelling red giant sun. The spacecraft will continue its journey, carrying that golden record through a universe that will itself have changed in ways we can barely begin to imagine over 5 billion years of cosmic time, and the record protected by the vacuum of space, sheltered from the kinds of degradation that destroy things here on the surface of a living world, will carry on. The gold plating, the copper disc beneath the stylus and the instructions for playing it, all of it drifting quietly through a universe that will be billions of years older than the one we know tonight. There are, according to our best current understanding, more than 100 billion galaxies in the observable universe. Each of those galaxies contains, on average, hundreds of billions of stars. The numbers are so large that they lose their edges. They become soft and hazy the way very distant things become hazy, and perhaps that is all right. Perhaps it is not necessary to hold the numbers firmly in your mind, but only to feel the gentle weight of what they suggest, which is that the universe is almost incomprehensibly full of places, of light, of the possibility of warmth and complexity and whatever might emerge when the right conditions arise over the right spans of time. We do not know what is out there. We have not yet heard an answer to the quiet question that the golden record asks, simply by existing and traveling. But the universe is very large and very old and has not yet finished whatever it is in the process of becoming. Voyager moves through all of this, through the dark between stars that are themselves separated by such distances that a human life, even many human lifetimes, would not be enough to cross from one to the next, even traveling at the speed of light. It moves through regions of space where the density of matter is so low that a cubic centimeter of the interstellar medium might contain only a few atoms, where the temperature hovers near the coldest extremes that nature allows, where there is no weather and no season, and no sense of the passage of time except through the patient motion of the spacecraft itself, which serves as its own kind of clock. Its position a record of how much time has elapsed since a warm September morning in 1977 when it left the surface of a living world behind. And on board, always, the golden record turns or does not turn, waits, rests in its mount, silent and patient, and filled with the full and tender strangeness of what it means to be human. It carries the heartbeat of a newborn child and the formal greeting of a United Nations Secretary General. It carries the sound of the surf at the edge of an ocean and the precise mathematical description of what DNA looks like, and the music of a Senegalese percussionist and a Georgian choir, and a Navajo night chant and Mozart, and a blues song called Dark Was the Night, Cold Was the Ground, played by the guitarist Blind Willie Johnson, who recorded it in 1927. 50 years before the spacecraft that now carries it departed the Earth, a man who could not have imagined this, none of us could have imagined this, and yet here it is. The music traveling through the dark between the stars in the only way we knew how to send it. Whatever Voyager eventually encounters, whether it passes near another star in some distant future epoch, whether it is captured by some gravitational field we cannot now predict, whether it drifts through the interstellar medium for longer than the current age of the universe before anything touches it, it will carry those things with it always. The heartbeat, the music, the greeting offered in 55 human languages to whoever or whatever might someday hold the record in their hands, or their equivalent of hands, and understand that somewhere, at some point in the long unfolding history of this galaxy, there was a small blue world, third from a yellow star, where creatures looked up at the night sky with something between wonder and longing and decided in their quiet, improbable way to reach. And perhaps that reaching is enough. Perhaps the act of sending, the care that went into choosing what to include, the hours of deliberation over which piece of music, which photograph, which spoken word would best represent the full and complicated beauty of life on Earth. Perhaps all of that is itself the most human thing that Voyager carries, not recorded on the disk, but written into the very fact of the mission, into the decision to look outward rather than inward, to say hello to a universe that had not yet said hello back. Tonight, as you let your eyes grow heavy and your breath slow and deepen, Voyager is out there, moving through a darkness that is also full of ancient light, passing through a quiet that is also full of the remnant radiation of the universe's own beginning, drifting through a space that is, despite appearances, far from empty, threaded through with magnetic fields and cosmic rays and the slow, invisible ballet of particles that have been traveling since before our sun was born. And somewhere in all of that, small and gold and carrying everything we thought to give it, the spacecraft moves on, a seed cast into an infinite garden, carrying with it the warmth of every human hand that helped to build it, the voice of every person whose work made it possible, the sound of rain falling on a planet where, for at least one brief and luminous moment in the long history of the cosmos, something woke up, looked around, and found the world so beautiful it wanted to share it. The stars receive it in their silence, neither welcoming nor indifferent, simply there as they have always been, patient and burning and impossibly far away. And Voyager drifts among their light, like a whispered word released into a very large and very quiet room. Still traveling, still carrying its golden gift, moving gently through the dark with all the tender, unhurried certainty of something that has nowhere to arrive and everywhere still to go. And so Voyager drifts on, carrying our whispered dreams into the infinite dark, just as you now drift gently into your own quiet universe. This journey is complete, dear traveler. If sleep has not yet found you, another soft chapter waits whenever you're ready. But for now, let the stars grow distant and your breathing slow. You are safe, you are still, you are home. Good night, sweet soul.